Hello there, ATS 211 students. Dr. John Schragi here, and I'm welcoming you to the class, and I appreciate all your patience with all the craziness between having trouble getting the class scheduled and sickness, and then a bunch of snow days or ice days or whatever. You guys have been through a lot at the beginning of this semester, but we'll make it all work out. Don't worry, you're going to get a good experience in this class. Because that's the kind of thing we do, let's go ahead and talk about the syllabus right at the beginning of the course here. Hopefully by now, by the time you see this, you've actually gotten the syllabus. I don't know if I'll email it to you or just send you the link or whatever, but it'll be available to you all in Blue Line as well, of course. This course, I'm listing it here as if it's online. Obviously, it's going to be kind of a hybrid, partially on Skype and partially pre-recorded like this. Just because of the scheduling and the nature of the material and so on. And you have all my contact information and so on there. They make us on syllabi tell you office hours. I'm not sure in this particular case that's all that relevant because I'm kind of here all the time and yet never here. As I think some of you know, I have two great kids. One of them happens to have cerebral palsy, and so we have a lot of therapy appointments. I mean, that's part of the reason why changing to an online teaching position worked really well for me, is because I take him to like 8 therapy appointments a week. And so the point is, if you send me a text, if you even call me or whatever during the day, if I'm available, I'll be glad to talk to you right that exact minute. On the other hand, if like I'm in and for that matter, a lot of the time I'm just sitting in a waiting room waiting for some speech therapist or something, I'm perfectly willing to talk to you then. If I can't talk to you right at that exact moment, or we can't chat or whatever, we'll set up a time that we are available. I mean, we're gonna be flexible with each other about these kinds of things. Okay, I've been doing this for over 3 years now, and I know how to make it work. Okay, we'll be okay with this stuff. But anyway, so we're not really going to like worry about office hours so much. Although at that particular time, 9:30 to 10:30, I will always be here. I blocked out that period of time. I never have meetings at that time. Anyway, there's no textbook for this course. There's no single resource that would really cover the kinds of materials that we're going to be doing in this class. And I liked what it said in the university's handbook about this class. I've actually never taught this particular course at Creighton, although this is quite related to a course I used to teach at Purdue. So I'm actually pretty excited about it, and I think it's going to be really cool to see how this all works out. But the university catalog said that it's designed for students who are majoring or minoring in atmospheric sciences, or just non-majors interested in meteorology. I'd love to see more non-majors take this class, actually. ATS 211 investigates the basics of atmospheric circulation systems, both descriptively and quantitatively. I think that's important. We're going to be doing both, how to describe the atmosphere, like contours and thermodynamic diagrams and so on, as well as more quantitatively, how do we get information about the atmosphere and do things with it. Emphasis will be placed on display, interpretation, and analysis of weather data. Students will also participate in weather forecasts using current data. I know sometimes in the past they've done things like forecast games in this class. I'm not a huge believer in forecast games. Don't get me wrong, I think they're fun. Where we set up a web page or something like that where students have to make forecasts every day for a particular location. I'm just not sure that I think that they're much of a teaching tool. I think it's really hard to set something like that up where the students are actually becoming better at forecasting versus they just learn how to game the system. And so I don't anticipate us actually having a forecast game so much as we'll have forecast discussions and make forecasts and work on them together and so on. But that's not till the second half of the class. The first half of the course is all going to be about weather analysis, depiction of the atmosphere, thermodynamic diagrams, station models, contour lines, different coordinate systems, quantities that we use to describe the atmosphere, like advection, vorticity, flux divergence. I don't even remember what all ones I've got planned out here. But ways of describing what the atmosphere is doing. The second half of the class, I do think we're going to do a lot more forecasting and analysis and so on. In particular, I think, too, we're going to be using some of these training modules that come from COMET. COMET is the Cooperative Meteorological Training something or other. Anyway, COMET. They make modules that you can use online to become familiar with the operations of a particular forecast system or something like that. And frankly, I couldn't do better than what they've already got, and we can just use it. So I think it would be, in that way, it would be consistent with what later in your career and so on, you would encounter people who have done those same training modules as well. So I think we'll use some of those modules along the way as well that are available to us from Comet. It says here we have to formally give some course requirements, and so I kept this language in here about it's assuming that you've already completed your understanding science and doing science, natural science component of the Modus core. To be honest, I'm not really sure why that's even in there, because I can't imagine there'd be that many people interested in this class who haven't at least completed ATS 113 and 114. But that being said, I don't think that's a deal breaker either. If you haven't completed those, just let me know, okay? If you haven't taken the intro class, fine, then let me know and we'll get that sorted out, okay? We're going to do a lot of processing of maps and stuff in this class. Some of it's on paper, and some of it will be working on a computer server where we're going to be running specialized meteorological software. No matter what, turning the assignments on time, okay? We'll have to have some kind of policy and rubrics and so on about, like, what do we do when assignments come in late and so on. With only a handful of you in the class, I'm not anticipating that being a really big problem, but you never know. And we don't want to develop any bad habits or anything like that. So turn it in on time. You can see the exact business here about, like, you know, what the policies will be on all that. In a class like this, with so few students, attendance really is very important. It's a very difficult thing to fix when one student isn't there on one of the days that we meet via Skype and so on. And so if you can't be in attendance when we are doing one of those Skype lectures, please let me know in advance, because then we can make arrangements to do things like record it, okay? If we don't record it, I kind of end up just teaching it a second time to an individual, and that doesn't really work very well. So make sure that you let me know in advance. If attendance becomes a problem, I have the right, as it explains here on the syllabus, to initiate what's called an attendance failure procedure, where if you've missed, this is true, by the way, of any of your courses at Creighton. If you've missed the equivalent of 2 weeks of the class, so like on a Monday, Wednesday, Friday class, if you have 6 unexcused absences, on Tuesday, Thursday class, you would be talking about 4 unexcused absences. If you've missed the equivalent of 2 weeks of the class, you can get a grade of absence failure, AF, on your transcript. You don't want that. I'm usually a little bit more explicit than other instructors about saying that on these syllabi, just because sometimes students get into bad habits with classes that are online or taught via YouTube or whatever. So let's not go to that dark place, okay? Let's just not get in the habit of having some bad attendance and so on. Let's see here. Again, being academically honest is important in all your classes, and that link to the College of Arts and Sciences page about academic honesty and so on, and academic dishonesty really applies to all your courses. I'm not really anticipating a lot of academic dishonesty issues in a course like this, because you are certainly allowed to work together. I mean, you know, if you want to make a study group where you're working together on maps or learning from each other about how to use the software or something like that, I don't consider that a bad thing at all. Okay, you turn in the exact same assignment or something like that, that's going to be a problem. But, you know, I'm not anticipating there being a big problem with, like, cheating on the exams and so on. I don't think this is that kind of class. Anyway, so, but again, the university has a checklist of things that must appear on a syllabus, and let's just make sure it's there. Grades, I have the same grade scale that I paste into every class that I teach, that I did to the syllabus of every class. You know, we're like 90 and above's an A and all that kind of stuff. In practice, I have no preconceived idea as to what the grades in the class are going to be like. I'm not really anticipating anybody getting a terrible grade in this class or anything like that, but I mean, if you have an 89, don't assume that means B+. That's, you know, we'll curve if needed or whatever. I mean, that's not really the issue. I'm not that worried about, like, you know, sticking to this exact curve. As far as how the grades are going to be determined, I think I can't really come up with a better plan than the old-fashioned way of just doing it with a midterm and a final. Considering the course kind of has 2 halves to it, a half about analysis and a half about forecasting, so taking a test at the end of the part about analysis and taking a test at the end of the part about forecasting just makes sense to me. And then along the way, you're going to have done a lot of stuff, and those will add up to like 50% of your grade as well. We'll learn more about the format of the tests and how you'll take the tests and all that kind of stuff as we get closer to it. We're a long ways away from that just yet. And that's all I put in the syllabus, okay? I'm not really anticipating there being some of the other kind of problems that we have to have an explicit calendar and so on. There's only like 3 of you guys. It's not going to be a big problem. We're going to get it worked out. Alright, so anyway, we went over the syllabus. It's not really that big and complicated of a document for this particular course. Again, I've never actually taught this particular course at Creighton, but I've taught very similar things at other schools, and I think we're going to find good ways to make this all work out really well. Alright, then I'm going to switch over here to the PowerPoint presentation that we have for today, which is just called the first day of ATS 211, and we're going to work through here some kind of the beginnings of thinking about ways that we're going to depict the atmosphere, which will lead us to our first assignment here. So, okay, we've gone over the syllabus, and we know what all that means, and so on, okay? So what I want to start talking about is observations. Now, this is a very common thing to talk about, like the first day of any kind of science classes, talk about like how you measure and what you do with that information and so on. And so in the context of a meteorology class, we're talking about things like where do we get observations and how do we share them, how do we encode them. Encode here doesn't mean as in like make them, so we can't, like they're secure or something like that. Encode as in how do we put them into a standard format that anybody around the world can read them. And how do we plot them, how do we visualize them, etc. I'm just stealing some slides here that I use in some of my other courses, so some of you guys have already seen this. But there is a whole network of these operational surface weather stations around the United States. In the United States, operation of that network of weather stations at the surface is done by some combination of the National Weather Service and the Federal Aviation Administration. Both of those entities have congressional authority to, or a mandate or whatever, to observe the weather, but for different purposes. The National Weather Service's charge is more about public safety and agriculture. It comes from the fact that back when it was the Weather Bureau, not the National Weather Service, it actually was part of the Department of Agriculture. Whereas the FAA is explicitly in the business of like safe and efficient flight operations and so on. So they have slightly different mandates as to why they do it, but in practice they work together to operate these networks of stations that observe all around the surface of the country. Now, just so that we're all on the same page here, this word station can be confusing to people because they often think about station as in like TV station. Okay, this is the sense of the word station as in stationary. I always associate more with like train station, okay? As in, it's a place we have established and it's not moving, okay? So we have all of these stations, which are depicted by these little red dots on this map here. I'll zoom it in so you can see it a little better. Where some combination of the FAA and the National Weather Service are operating these kinds of weather stations at these locations here. And they are by and large co-located with airports. To be I can't think of the entity right now. There's an international entity that certifies that airports are safe to land at and so on. To be an actual airport where like flights can land and so on, you have to have certain levels of information available to the pilots, not the least of which is like the visibility and runway conditions and so on. So it makes sense that they operate these observation stations at airports. There are some that are more like at ag research stations and so on. Some are physically co-located with like National Weather Service offices where like people are producing forecasts and so on. But by and large, if you're thinking of these as airports, you're doing a good job. And I mean, if you take a look closely at, like let's say Nebraska here or something like that, well, it should be clear to you that they are, the locations of these airports, we aren't necessarily talking as in like, a commercial jet is landing there. These might be more like for private flights or whatever, but, like for example, you might see Norfolk on there. Now the station identifier, the code for the airport and the weather station that is in Norfolk is KOFK, and you can see that there kind of in northeast Nebraska there. And I just pulled that one there as an example. I mean, you can't fly commercially. Oh, I think you can actually now fly commercially into Norfolk, but in general, these airports are not places you can in general fly commercial, but they still have to, because there can be private flights and so on, they have to have hourly surface station reports from them. I pulled up this particular map to give you a sense as to how many there are. There are somewhere in the ballpark of 30 to 40 of these stations operational in Nebraska. The map that I show you here does not have all of them. because some of them are so close to others that they would overlap if plotted on here. For example, in the Omaha area, KOMA is actually the weather station that operates on the site of Epley Airfield downtown, well, just north of downtown, whereas there is also KOFF, which is Offutt Air Force Base, and I can never remember it, but Millard Field, out on the southwest side of town, is a small single runway, kind of out by the interstate on the southwest side of town, and I think it's KMIL, but I'm not sure. And there's one on the north side of town, KOVN as well. That's the old North Omaha field. The point is, there's quite a few stations just in a 10-mile radius around Omaha. They would overlap. But in general, you get a pretty good sense here as to the station identifiers. It's quite confusing that all these station identifiers start with the letter K. KOLN is O'Neill. KBIE is Beatrice, Nebraska. KOMA is Omaha. The K is the code in the World Meteorological Organization for in the United States. Okay, it's a complicated story as to why it became K, but that's another story. So like OMA, well, if you've flown into Omaha's airport, you know OMA is what it says on your luggage, okay? OMA is the code for the airport, KOMA is the station there. It's confusing, of course, because in the United States, many radio stations and television stations also use the K. That is unrelated, okay? That is a different reason for that versus this. Anyway, so here you can see the station identifiers for many stations across Nebraska. And do you need to learn these? Yeah, I mean, it's kind of a thing in meteorology to make sure that you know the station identifiers, at least in the area of your operation, okay? If you were a forecaster working in flight operations over, a flight route in Texas or something like that, knowing the names and identifiers of the stations in your area would be kind of a useful skill. More importantly, it'd be kind of alarming if you didn't know them. So you will be learning these with time, okay? It doesn't necessarily mean you have to cram them all in right today. At each of these weather stations here, they, in general, observe the weather hourly. And report it back, and we'll learn about that process in just a little bit. There are some weather stations that report every 30 minutes. There are some weather stations that report only every 6 hours. It has to do with like the flight operations that are done at that station and so on. But in general, if you think of these reports as being hourly, you have the right idea. They do have the ability to transmit what are called special reports if the weather conditions are changing rapidly. If, like, when a front passes or something like that, there will often be triggered these special reports that get transmitted that help, for like tracking fronts and so on. In general, these weather stations are unmanned. If you have the idea that like there is a meteorological technician who is there every hour, goes outside and takes the observations, that is in general not how it is done. In general, these are various forms of automated systems. And you'll hear all these acronyms like ASOS and stuff like that. That's not important in the context of this course, okay? The idea, though, that in general they are an unmanned station that uses electronics to gather observation. Now, there are humans who come and calibrate the instruments on a routine schedule and so on, but the basic idea that these are unmanned stations working autonomously is a good idea to have. Once the equipment gathers observations, and we can talk at a later date about what kinds of observations they all gather and how they do it, if that's something you want to learn, but once they have that information, they have to have some way to transmit that information around the world. There has to be some way that we can take the information that was gathered by those instruments that are out by a runway at Epley Field, and they need to be distributed to anybody who wants them, like for forecasting purposes, aviation purposes, research, climate studies and monitoring, teaching, whatever. Okay? Those observations belong to us. Okay? They're not a copyrighted thing. You can't copyright the weather or whatever. There's no good in having information that isn't distributed when it comes to weather information, right? It perishes very quickly. And so, now, in terms of the mechanics of how that is done, that's actually really interesting and important, something we're going to be doing later in the semester. How does that observation that just came in from Epley Airfield get transmitted all around the world what kind of networks are used to do that, and so on. But that's a topic for a later lecture. In the meantime, though, I want to tell you about, like, you are now the recipient of that data. Like, you're a forecaster and you just saw, oh, a new observation just came in, it's the top of the hour and we have new observations. What are they, what kind of formats are they in? How do you get this information? Turns out the data that are taken out there and the observations that are gathered from these National Weather Service and FAA stations are transmitted in two formats, one called buffer and one called METAR. Now buffer's kind of the future. Buffer, which is a horrible acronym for Binary Universal Form for the Representation of Meteorological Data, whatever, is kind of a future. It's a newish, I mean, I don't know, it could be 20 years old already at this point, but slowly being adopted format established by the World Meteorological Organization, a Switzerland-based entity that kind of provides oversight to national meteorological services all around the world. And buffer is meant as a replacement that will be globally used, and it replaces all the weird kinds of codes that every other part of the world uses and aren't necessarily all that standard and are hard to decode and so on. Buffer's pretty neat. You can transmit lots of different kinds of meteorological information in buffer. Anything from radar data, satellite data, upper air data, balloon data, model data. Buffer is a very useful thing, but it is not something humans can read. Buffer is a file in binary that a computer generates, and then another computer can read that file and decode it, and it can be anything. And you and I, as mere mortals with our simple senses and simple brains, cannot look at a buffer file and know what to make of it. Rather, the data are also still transmitted in something somewhat readable by humans in a format called METAR. Some people say METAR, some people say METAR. I have to admit I go back and forth. I don't really care how you pronounce it. METAR is a text-based standard for transmitting meteorological data at the surface. It is ASCII text. It is letters of the alphabet and numbers and spaces and symbols like plus and minus and slash and stuff like that. It's very, very simple symbols like this. And it's a code, it's a standard pattern that we use for transmitting this data. It's not just saying text, hey, the temperature here is 53.6 degrees. It's a format that computers can read and humans can read and so on, the data. The actual term METAR is an acronym. It's a French acronym, and it's usually translated as Meteorological Aviation Report, just because Meteorological Aviation Report looks like I can see how that could be METAR. Okay, it's not quite that simple, and my French is non-existent, so we won't worry about beyond that. But METARs are surface reports, and they are in a format, well, they're text. They could be read by humans. And so, for example, I just cut and paste from a file that came in that had observations, a observation in METAR format. KOMA space 1425152Z space 03007KT space. What in the hell is all this? Well, it's a weather observation. Now, we could sit down here and learn about each of these little blocks of text. See how there's little blocks of text separated by spaces? Like, probably not hugely shocking that that first one, KOMA, is the station identifier. In the United States, they all start with K, but in other parts of the world, they start with different letters. Okay? Space. Now, the next block of text there is 142152Z. That is the date and time. This case means the 14th of the month at 2100 hours, well, 8 minutes before 2200 hours Greenwich Mean Time. Now, we'll learn more about all of that in a later bit, but the point is, see how it breaks up into these little individual words and so on. So you can see how it's all broken up like that, and there's little, like, okay, so 1412, okay, so that's the 14th, the 2152Z, we can talk more about how to read time later. The next group there, 03007KT, that is a symbol that talks about the wind. Now, I could sit here and pull through all these little symbols and so on, but that just isn't productive, okay? A much better use of your time and my time is I have given you a handout on Blue Line that has all the information about how to decode one of these. So just go ahead and get a copy of that handout, and that will help. I do want to draw your attention to a couple quick things. One is that the temperature information, which is what's separated here with that slash, that is the temperature and the dew point measured in Celsius. So here 02/01 means that it was 2 degrees Celsius was the temperature and 1 degree Celsius was the dew point. Another thing I want to draw your attention to is that the winds are reported in terms of azimuth, as is the meteorological practice, where the direction of the wind is described in terms of degrees, where 0 degrees is from the north, 90 degrees is from the east, 180 degrees is from the south, and 270 degrees is from the west. We always describe winds in terms of where they're coming from, and it's in terms of azimuth from the north. Now, I have a screenshot here that shows you a whole bunch of METAR observations that I have on my server at the moment, and they're kind of a mess. I mean, when you take a look at them, it's very difficult. I mean, an individual METAR can be quickly read if you have some experience with it, but the actual pattern here of like trying to figure out what the weather is doing doesn't make a whole lot of sense. It's hard to make sense of something like this. There's just no way to get a sense of the pattern or whatever. That's why we need visual depictions of what the weather is doing. And we're going to get to them. We're going to be doing things like that colorful map over there where we have color-filled depiction of the surface temperature on today. And we'll be using software to do something like that. And like, for example, the kind of weather diagram that you see over there on the left, which is called station models, where we are getting a whole lot of weather information, temperature, dew point, pressure, winds, and so on in one kind of plot. Admittedly, a plot that's a little hard to read. Let's focus on that first one here. We're going to start with the one on the left, the so-called station models. So at each individual location of a weather station, we're going to plot a whole bunch of weather information in the form of a station model. The station itself is at the location of the little circle that kind of makes the head of the symbol there. And then there's different positions of different pieces of weather information. The wind information comes from the so-called wind barb, which is the part that sticks out and the little barb points upwind. I think you probably knew that from like ATS 114, but if you didn't, it points upwind. Let me give you a little couple. We're going to use the same kind of pattern about learning about weather station models as we do with learning about METAR. It isn't really your best use of time or my best use of time to sit here on YouTube and go through how each of those positions of each of the symbols on there work, so much as I've given you a handout on Blue Line called something like Decoding a Station Model or something like that. Go ahead and get a copy of that and use that to complete assignment 1. Just to give you a couple quick hints, though, as to things that you might see when you do decode a station model. It's important to know that METAR reports code temperature in units of Celsius, but surface station models use Fahrenheit. I have no idea how that discrepancy ever came to pass, but you do need to convert Fahrenheit and Celsius back and forth when you're plotting these, and that's what you're going to be doing on homework 1, is you're going to be taking METARs and plotting them as station models. So if it says that the temperature is 2 degrees Celsius, you need to convert that to Fahrenheit. Okay, you can go ahead and round it to the nearest degree, that's fine. If it seems like to the nearest degree isn't accurate enough with those measurements of the temperature in Celsius, there are ways that they actually can go to the 10th of a degree Celsius, but we're not gonna get just too bogged down in how all this is done. Okay, obviously we're going to quickly move beyond working with the raw METARs and talking about more impressive types of analysis we can do. Suffice it to say, we can get the observations down to a 10th of a degree Celsius. Alright, so when you are going in and doing this, like for assignment 1, you do need to convert the Celsius to Fahrenheit. Honestly, don't sit there with the equation. Well, yeah, I can't tell you not to do that, but sitting there with the equation that converts Celsius and Fahrenheit back and forth, that's kind of a pain in the butt. You know, we live in a world. In Google Chrome, just type convert 2 degrees Celsius, convert 2C to F will work. It'll tell it to you. Or use Google Now or Siri or whatever you have. I mean, just tell it you need to convert 2 degrees Celsius to Fahrenheit. It'll be fine. Okay? So you're going to be making, plotting the temperature there. As you'll learn, the temperature is plotted to the north and west of the station, and the dew point is plotted to the south and west of the station. That's part of the symbols that are around there. You're going to be plotting the temperature and the pressure and the dew point and the winds on there. The wind barbs, remember, point upwind. And then the flags and pennants, the flags are the single sticks that kind of go on the side of the bar, and the pennants are the little triangles. I don't think there are any pennants on these that are on the example here, with little triangles. They code up the wind speed, and again on the handout that I give you, it shows you examples of how to do that, where each full bar is, I think, 10 knots, and every half bar is, half flag is 5 knots. Anyway, so how you code up the wind speed is given in there. I will give you a hint. When you plot those wind barbs, the flags and the pennants that go on the side of the wind barb should always be kind of set up so that they make a capital F shape. Okay, when you draw those barbs, then make the flags point off to the side so that it makes the shape of a letter F. You can kind of see some examples over here. That's really so that it points towards the center of low pressure, but in the northern hemisphere we make them, so they make like the letter F. Let me know if you have any questions about that, and I'm hardly going to take off huge amounts of points if you have that wrong. So what's going to happen then in this assignment that you'll get off of Blue Line is that there is, I don't remember exactly how many I used, I just gave you some raw METARs for stations in Nebraska, and I want you to decode them and plot them as station models on a provided map. Also on a piece of paper there, I just want you to give me the name of the city that each of those is as well. You might have to look up on the map or on a database or something. I'll invite you to discover for yourself using Google or whatever, what is the name of each of the cities? What is KOFK? What is KBIE, etc. And to turn it in. When it comes time to turn it in, let's just take the path of least resistance here. Obviously, if you want to scan it and send it to me as a PDF file or whatever, that's fine. A path of least resistance would be just to snap pictures of each of the pages, fairly well lit or whatever with your phone, and then turn them in on Blue Line that way. That's fine. You can, if you're used to probably in Blue Line to turning in Word documents and stuff like that, you can turn in anything that way, GIFs or JPEGs or whatever, it's fine. So whatever it takes, if you just want to email me the picture, we'll make it work. Okay? The mechanism of how to turn it in is not really what I'm worried about. Okay, I think that's everything that we need. Please let me know if you have any questions, and I apologize for the kind of disorganized start to the class this semester, but we'll get it all worked out. All right, let me know if you have any questions, and have a great day.